lesson or learning goal 18. This is powers using repeated multiplication. Now, in a little bit of review here, a power is a combination of a base with an exponent. Okay? Every single number can be written as a power. Okay? Many of them would just be that number to the power of 1, but we could also write them in other ways as well, or some of them we can write as other ways. Now, the value of a power can be expressed using a term called repeated multiplication. Okay. By doing this, the standard value of the power can be found. Okay, so if we see a power with a base and an exponent that is not 1 or 0, okay, it might be a little bit difficult to figure out what exactly that means. Repeated multiplication gives us that opportunity to see exactly what does that mean when we multiply the entire thing out. Now, repeated multiplication is multiplying the base by itself the number of times that the exponent expresses. Okay. By completing the multiplication process, the value of the power can be found. Okay. So when we're writing it out as repeated multiplication, something like 3 to the power of 5, if we write it out as repeated multiplication, it's 3 multiplied by itself until there are 5 3s. Okay, 1, 2, 3, 4, 5. Okay, we're not multiplying by 3 5 times, it's just the 3 being multiplied by itself. There's 5 of them. Okay, and that's an important thing to recognize. Okay, we're only going to have 5 3s in here. Now, if we were to actually solve that, okay, to solve it, we would multiply the 3 by itself as visualized in the repeated multiplication. 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, times 3, which is 243. 3 to the power of 5 is the same as 243, which is 3 times 3 times 3 times 3 times 3. Now, if you want to check that on your calculators, you definitely can. You might want to pause this video and just double check that Mr. Barkman did all the math correctly, okay? Because even Mr. Barkman sometimes makes mistakes, and that can happen on videos as well, especially because Mr. Barkman doesn't like to redo videos necessarily, especially when he's 3 minutes in. Now, so that's how we can solve for what the base of our, or sorry, what the standard value of it is. Now, if the base is a negative number, okay, the negative must be multiplied, okay, numerous times. Okay. Now, when we deal with that, and this is something that I'll show you in an example in just a very little bit, okay, or in our next examples, if the exponent, okay, is an even value, okay, now remember, even is 2, 4, 6, 8, then the final answer will be positive. Okay, and this is using multiplication with negatives, with integers based on what we've seen in the past, and we'll go through why that is in just a little bit. On the other hand, if the exponent is an odd value, okay, the answer will be a negative, or it will stay as a negative. Okay, let's solve the following ones, and we're going to see exactly what we mean. So negative 2 to the power of 4. This is negative 2 times negative 2 times negative 2 times negative 2. Now you'll notice here I didn't put the multiplying sign in there. We don't need it if we have brackets. We can just put the brackets side by side. You could put it in there if you'd like. You can gladly do that. You don't have to. Okay, you don't have to do that. You can just write it out in the brackets there. Now, again, following order of operations, we do the first two first. Negative 2 times negative 4. This is 2 negatives, so the answer becomes a positive. Okay, so it is a positive. Next, we do these two. Okay, 4 times negative 2, and I'm going to put that up here, is negative 8. Notice how it's a positive times a negative, and so we now get a negative as that answer. And finally, we do the last one. Negative times a negative gives us a positive. So the final answer is a positive. Notice how it's an even number of times. we get a positive answer out of there. If we do it an odd number of times as such here, negative 2 to the power of 3, which we've actually already kind of done, so to speak, it's just one less. Okay, when we multiplied it out the first time, we got these two became a positive 4. And we're multiplying it by negative 2. Now when we multiply these two together, okay, to get our final answer, we're going to get negative 8, which we did up here. And you'll notice an odd exponent gives us a negative value, an even exponent gives us a positive value. Now this only is the case if the base of the number is a negative. Okay, so that only is the case if the base of the base of the power is a negative. Now if the base of the power is has a negative in front of it, but not in brackets, you'll notice here it's in brackets here. Okay, so that means that negative 2 is in fact the base. Okay, and prior we looked at what the base was. The final answer will always be negative. Okay, or it would actually be opposite of what the actual answer would end up being. The base of this power is not negative. Okay, the whole power is negative. So the entire power is negative, not the base. Here the base was negative and the answer became positive. If the negative is on the outside of the brackets, okay, then what it does is it actually makes the entire power negative. Okay, no matter what is inside, what the exponent is, the entire power will be negative. So if we're going to write out something like negative 3 to the power of 3, using repeated multiplication, we're going to put a negative in front, and then we're going to do 3 times 3 times 3. This is a negative 3 to the power of 3. Okay? It's not negative 3, it's a negative 3 to the power of 3. And so the negative goes there. We do 3 times 3, which is 9, times 3, which is 27, and it makes the entire answer negative. Okay? This is 27. Okay, the negative makes it negative 27. Now, we could also see a negative outside of a negative, and I'm just going to show you an example of that, even though it's not in the notes right here. So if we have like a negative 3 to the power of 3, okay, this is a negative 3 times negative 3 times negative 3. This right here is negative 27. And it's a negative 27, which gives us actually a positive 27. Okay, there is a couple questions like that, or at least one question on your assignment that looks like that. Okay, if you're unsure of how this exactly works, I can talk to you in class. We can go through it in class as a question. Please ask. Don't just assume that, or don't just leave it and assume that it will, be fine. Because there's going to be a couple questions like that, so make sure that you ask questions, or even text me or send me just a message based on that. All right, let's write each repeated multiplication as a power. 4 times 4 times 4 times 4 times 4 times 4 is going to give us 4 to the power of 6. Negative 7 times negative 7 times negative 7 times negative 7 is going to give us negative 7 to the power of 4. And negative 2 times 2 times 2 times 2 times 2 is a negative 2 to the power of 5. And you'll notice here, this is just all positive. This one here is a negative number to the power of 4. And this one here is 2 to the power of 5, but the whole thing is negative. So that means that the entire power, including the final answer, will be negative or opposite of what we would end up getting, like we saw in this one right here. Questions 1 to 7, that is your assignment for this video, for this lesson. And there, make sure that you again hand those in. And if you have any questions, please send me a message and let me know what I can help you out with.